Question 6, we have f and g, two functions. Find out when they're equal. So the dread of, oh god, they've given us something easy. What's coming next? X plus 4 is equal to x squared minus 2. X squared minus x, bring the 4 across, minus 6 is equal to 0. And this factorizes to be x minus 3 by x plus 2. So the two values will be x is equal to 3 or minus 2. Just want to check that. So if we put x plus 4 is equal to x squared minus 2, so if x is equal to 3, we get 7 is equal to 9 minus 2, 7. So that works. And if x is equal to minus 2, we get minus 2 plus 4 is equal to minus 2 squared, which is 4 minus 2. We get 2 is equal to 2. So both solutions work. Area of the shaded region, so just integration, normally the top one minus the bottom one. So we set it up as f of g, the area is underneath, so we're looking for the area between 2 and minus 1 of f of x minus g of x. If you do g of x minus f of x, you just get the same answer but a negative or a positive depending on which side it's on. So we have the integral between 2 and 1 of x plus 4 minus, just be careful that it applies to both, minus x squared minus 2 with respect to x, which is going to be x squared x plus 4 minus x squared plus 2. So if I tidy this up, it's going to be the integral between 2 and minus 1, be careful, of minus x squared plus x plus 6. So if I put 2 in first, I'm going to get minus, sorry, to integrate it first, minus x cubed over 3 plus x squared over 2 plus 6x between 2 and minus 1 is going to give minus 8 over 3 plus 4 over 2 plus 12. When I put 2 in, then I have to minus, put in minus 1, and I get minus 1 cubed, that's going to give a plus 1 over 3 plus minus 1 squared over 2, and then minus 1 by 6 minus 6. So this is going to get 12 plus 2, it's going to be 14 minus 2 and 2/3, which is going to be 11 and 1/3. Then it's going to be minus I'm going to get minus 1 over 3 by minus 1 over 3, so it's going to be plus 1 over 3, and I'm going to get plus 1 over 2 minus 6, so that's going to be 5/6, 5 over 6 minus 6 of 5 and 1/6 minus, so it's going to be 11 and 1/3 plus 5 and 1/6, which is going to be 16 and 2/6, 1/6, 3/6, 16 and a half square units for the area between the curves. I'd imagine there might be 25 marks at that point. So it's something that might look a bit tricky. It's integration again. We're told the integral of b e to the power bx, the x is equal to e, between b and 0 here, integrate. So a to the power of ax becomes 1 over a e to the power of ax. So that's the b part. So if we integrate this, we're going to get 1 over b times the whole expression, which is b e to the bx. So that's what we're going to get when we integrate it. B's will cancel here, so between b and 0, this whole thing is equal to e. I think that's what we have. So we have e to the power of bx, and we're putting b in for x. So we have e to the power of b times b, and then minus e to the power of b times 0 equals e. So we have e to the power of b squared, it's an unusual looking one, minus e to the power of 0, which is equal to 1, is equal to e. So why don't I leave the e to the power of b squared there, working out the value of b. So when I isolate b, that's equal to the e on the right plus the e to the power of 0 coming across, which is 1. So we could just use our rules of natural logs. B squared by the natural log of e, which is equal to 1. It's equal to the natural log of the right hand side. So b squared is equal to the natural log of e plus 1. Put that into your calculator maybe and get a decimal. B is equal to the square root of this for part 3. So maybe easier than it seemed. I suppose it's going to reward those that didn't panic.